ठीक है, वी शुड बी लाइव नाउ। देखते हैं, एक बार मैं चेक कर लेता हूँ। थोड़ा खांसते खांसते आ गए हैं हम। देखते हैं कैसा होता है। आज का टास्क मेरे लिए ये है कि जब भी मैं खांसूं या चीखूं तो फिर मैं म्यूट कर पाऊँ खुद को। बाकी मजा है। तो आज हम लोग फाइनली माइक्रो सर्विसेज की तरफ जाने वाले हैं। स्प्रिंग बूट एप्लीकेशन हमने एक छोटी मोटी बना ली थी और वो हमारी प्लेलिस्ट में ऑलरेडी है, आप चेकआउट कर सकते हो। उसके अलावा हम माइक्रो सर्विसेज की तरफ जा रहे हैं, तो माइक्रो सर्विसेज की तरफ जाने के रास्ते में हमको वापस से एक स्प्रिंग बूट एप्लीकेशन बनाना होगा और फिर उसको माइक्रो सर्विसेज पे डिप्लॉय करना होगा। नमस्ते। नमस्ते प्रथमेश। तो माइक्रो सर्विसेज का यही रूल है कि हम एक पहले एप्लीकेशन बनाएंगे और अ, बहुत दिन बाद, यस यस, बहुत दिन बाद। हाँ, तो क्या कह रहा था मैं कि हाँ, माइक्रो सर्विसेज का एक रूल कि हम एक पहले एप्लीकेशन बनाएंगे और उसको माइक्रो सर्विसेज की तरफ डिप्लॉय करेंगे। ठीक है। उससे पहले एक अनाउंसमेंट कर देता हूँ मैं। अनाउंसमेंट ये है कि जैसा कि तुम लोग बात कर रहे थे, एक कम्युनिटी बना लो और एक जगह पे हम लोग मिल पाए, बात कर पाए, उस तरह की जगह। तो वो अब बन चुकी है। उसका लिंक मैं देखता हूँ, एक मिनट। उसका लिंक है यहाँ चैनल के। हमारे अगर चैनल पे हम जाएंगे, इसको हटाता हूँ, मैं दिख रहा हूँ ना मैं, हाँ ठीक है। माइक्रो सर्विस तो ठीक है। चैनल के अगर तुम, मेरे में ऐसा आएगा ना, ये लिंक्स में देखोगे तो डिस्कॉर्ड का लिंक है यहाँ पे एक। तो ये लिंक से ज्वाइन कर सकते हो। ये लिंक मैं इसमें भी डाल देता हूँ चैट में, ताकि तुम लोग इस और ज्वाइन कर पाओ। एक मिनट देखो, यहाँ पे डाल देता हूँ डिस्कॉर्ड लिंक। क्या मैं यहाँ पे लिंक पेस्ट कर सकता हूँ? कर तो सकते हैं। देखो ज़रा, ज्वाइन कर पा रहे हो क्या इस लिंक से? नहीं कर पा रहे तो हम लोग देखते हैं। और इस लिंक पे क्लिक करने पे क्या ओपन होगा, मैं भी देख लेता हूँ। हाँ, तो हमारे डिस्कॉर्ड का जो नाम है वो हमने रखा है पम कोड। पम कोड हमारा चैनल होगा आगे जाके, जो हम सब मिल के मेंटेन करेंगे। हम सब का मतलब, मैं चाहूँगा कि इसमें हम लोग मिल के चीज़ें करें। अभी इसमें जो जो चीज़ें हैं वो मैं एक बार बता देता हूँ। तो इसको ज़रा, क्या है ये? स्ट्रीमर मोस्ट रिजनेबल यूजर ट्रंकेटेड डिसेबल, हाँ ठीक है, जो भी कम्युनिटी रूल्स हैं उसमें कुछ खास नहीं है। बेसिकली नो बुलशिट, हम सबको पता है कि क्या करना है, क्यों बना है ये चैनल। तो वो थोड़ा ध्यान रखना है, एक दूसरे की थोड़ा रिस्पेक्ट करनी है, स्टे ऑन टॉपिक रहना है। सेल्फ प्रमोशंस ना अधिकतर चैनल्स में मैंने देखा कि वो लोग नहीं करते अलाउ, है ना, तो हमने इसका एक अलग से चैनल बना दिया है। मैं क्या चाहता हूँ कि अगर आगे जाके तुम लोग यूट्यूब चैनल ओपन करो या फिर तुम लोग कोई ब्लॉगिंग करो, कोई प्रोजेक्ट बनाओ, कुछ भी करो, तो तुम लोग यहाँ प्रमोशंस में उसको प्लेस कर सकते हो, है ना, डाल सकते हो, मुझे कोई परेशानी नहीं है। बल्कि मैं भी जो वीडियो बनाऊंगा, अगर कुछ इंटरेस्टिंग मुझे लगा तो मैं भी इसमें डाल सकता हूँ। तो उस तरह से हम रख लेते हैं इस प्रमोशन चैनल को, है ना। मुझे कोई परेशानी नहीं है अगर तुम लोग कुछ करके डालते हो, तो मुझे एक्चुअली कोई परेशानी नहीं है। तो बाकी के हमारे चैनल स्पैम ना हो, उस वजह से यहाँ पे हम इस तरह डाल देंगे। स्ट्रीमर मोड इज enabled, यूजर हैव बीन ट्रंकेटेड। प्रथमेश ऑनलाइन आ चुके हैं, अच्छा ठीक है, बढ़िया बढ़िया, कर लो ज्वाइन। फिर ये है कंटेंट वंटेंट देख लेना, कुछ एक्स्ट्रा ना हो। प्राइवेसी, एक दूसरे की रिस्पेक्ट कर लेना, किसी ने अगर नाम बताया तो ये नहीं उछाल दो कहीं पे। प्रोफेशनल रखना थोड़ा सा, एनवायरनमेंट अच्छा लगेगा। और बाकी डिस्कॉर्ड के जो टर्म्स एंड सर्विसेज होते हैं वो हैं। तो ये हमारा वेलकम सेक्शन है, इंट्रोडक्शन। इंट्रोड्यूस योर सेल्फ में सब लोग अपने आप को इंट्रोड्यूस कर दो। मैंने छोटा सा टेम्पलेट बनाने की कोशिश की है, बट ज़रूरी नहीं है आप फॉलो करो इसे। चाहो तो करो, चाहो मत करो। बस मुद्दे की बात ये थी कि तुम्हारे बारे में सबको पता चल जाए कि कौन हो भाई, कौन हो। जैसे हिमांशु ने ज्वाइन कर लिया, नाइस यार। फिर ये है जनरल डिस्कशन। तुम्हें कोड या कोडर, हम इसको दो जगह ले जाते हैं, है ना। मैं नहीं चाहता कि हम सिर्फ कोड की बात करें, मैं चाहता हूँ ओवरऑल डेवलपमेंट की बात करें। ओवरऑल हम बात करें कोडर लाइफ की, अपने डेली लाइफ के इश्यूज़ की। कई इश्यूज़ हमारे टेक्निकल नहीं होते हैं, हमारे मोस्ट ऑफ द इश्यूज़ एक्चुअली टेक्निकल नहीं होते हैं, वो नॉन टेक्निकल होते हैं। कि मोटिवेशन की कमी, या फिर कुछ किसी से बात हो गई है, अलाइन नहीं हो पा रहे थॉट्स मैनेजर्स के साथ, या फिर इस तरह के जो इश्यूज हैं ना, वो हम लोग डिस्कस कर सकते हैं। मैं इसको बहुत जनरल कैटेगरी में बनाना चाहता हूँ, तो हो सकता है कि कुछ भी मतलब डिस्कशन हो सकता है इसके अंदर, है ना। ये चैनल बनाया जावा डिस्कशन के लिए। जावा में अगर कोई भी चीज़ की डिस्कशन करनी हो आपस में भी कर सकते हो, चाहो तो हम लोग भी मिलके कर सकते हैं, कोई दिक्कत नहीं है। मैं भी एक्टिव रहने की कोशिश करूंगा। देखो मैंने इंस्टाग्राम नहीं चलाया काफ़ी टाइम से, है ना, तो मेरे एक्टिवनेस की कोई गारंटी नहीं है, बट मैं इसको देख लिया करूंगा एक बार। मैं यूट्यूब पे पूरी तरह एक्टिव हूँ भाई। मैं ऑलमोस्ट हर कमेंट का रिप्लाई करता हूँ। यहाँ पे डीएसए डिस्कशन में आपको जान के खुशी होगी कि फाइनली आज मैंने 2 लीड कोड क्वेश्चन सॉल्व कर दिए, और जो क्वेश्चन में मैं अटका था उस टाइम जिसकी मैंने बात करी थी, वो सॉल्व हो चुका है, और बहुत ही इजीली सॉल्व हो गया, पता नहीं कैसे। तो मस्त है। हालांकि मैंने इजी से शुरू किया है, तो मैं बताऊंगा कि डीएसए में किस तरह फॉलो कर रहा हूँ। मैं बहुत बहुत एकदम नूब की तरह फॉलो कर रहा हूँ डीएसए। तो वो भी एक अच्छा वे हो सकता है, अगर तुम लोग भी चाहो तो हम उस पर डिस्कस कर सकते हैं। यहाँ पे ये रिसोर्सेज का चैनल है, किसी को कोई भी रिसोर्स मिलता है तो इसमें पोस्ट कर सकते हो, ताकि सब पूरी कम्युनिटी इसे यूज़ कर ले। ये अनाउंसमेंट्स का चैनल है। अनाउंसमेंट्स अगर मेरे पास कोई होंगी तो मैं कर दूंगा, और वैसे देख लेंगे। ये जॉब और गिग का लिंक है। फिलहाल मेरे पास कोई जॉब का लिंक नहीं है, पर हम लोग कई बार लाइव में हमने बात करी है इस तरह की, कि जॉब है क्या कोई, या जॉब कैसे करें, या इस तरह का। तो वो हम लोग, हाँ, ज्वाइन हो पा रहे हैं भैया, बढ़िया बढ़िया। तो जॉब गिग का लिंक मतलब, गिग का मतलब वो फ्रीलैंसिंग से भी हो सकता है। तो जैसे अगर कोई फ्रीलैंसिंग गिग आए या जॉब आए, तो यहाँ पे कम्युनिटी को शेयर कर सकते हो, अगर खुद करने का मूड ना हो तो ये कर सकते हैं। प्रमोशंस मैंने ऑलरेडी बता दिया। यूट्यूब वीडियो टॉपिक्स ये मैं बनाना चाहता था, तो अभी फिलहाल जो मैं वीडियोस बना रहा हूँ वो मैं अपने लिए बना रहा हूँ, तुम लोगों को बहुत अच्छे से पता है। एक जर्नी में है फिलहाल हम, और उसको फॉलो करते हुए आगे चल रहे हैं, है ना। तो एक बार ये माइक्रो सर्विसेज खत्म हो जाएगा तो हमारा रूट थोड़ा डेविएट होके रिएक्ट की तरफ चला जाएगा, जावा से हट के। जब वो रिएक्ट की तरफ जाएगा ना, तो हम लोगों के पास टाइम होगा कि हम लोग अपने जावा के कॉन्सेप्ट्स, जैसे ये अपना डीएसए हो गया, या डीएसए का मतलब हमारे लीड कोड क्वेश्चंस, और दूसरा इंटरव्यू क्वेश्चंस। तो इन दो की तरफ मैं बहुत बहुत ज़्यादा एक्टिवली ध्यान देना चाहूँगा। तुम लोगों को अगर कोई वीडियो टॉपिक लगे कि ये बनाना चाहिए मुझे, तो वो तुम लोग इसमें सजेस्ट कर सकते हो, और मैं इसको एनीवे प्रेफरेंस दूंगा और बनाऊंगा। ये है कोडर माइंडसेट। मुझे आए दिन बहुत सारे कोट्स और बहुत सारे चीज़ें ऐसी मिलती रहती हैं जो जो हमारे माइंडसेट के लिए बहुत हेल्पफुल हो सकती हैं। जिस तरह से हम सोचते हैं, हमारा मोस्ट ऑफ द काम, तुम मानो या ना मानो, हमारा मोस्ट ऑफ द काम कोड का नहीं होता। कोड तो 15 मिनट का गेम होता है। उससे पहले हमें बहुत कुछ सोचना होता है, प्लान करना होता है, कंसीडर करनी होती हैं अलग अलग चीज़ें। तो वो हम, जो माइंडसेट कोडर का होता है, इसकी तरफ मैं बहुत ज़्यादा एक्चुअली कंसर्न रखता हूँ। ये एक ऐसा टॉपिक है जो मैं बहुत क्लोजली मॉनिटर करता हूँ हर बार। तो ये इसकी तरफ मैं चाहूँगा कि मैं कुछ कर पाऊँ, कि कोडर कोड लिखने से कोडर नहीं बनते। कोडर बनने के लिए उससे काफ़ी सारी चीज़ें चाहिए होती हैं। तो ये वो चैनल है। तुम्हें कुछ लगे तुम भी शेयर कर सकते हो। आई थिंक ये सबके लिए ओपन होगा। सिर्फ एक कम्युनिटी रूल्स शायद सबके लिए ओपन नहीं होगा, क्योंकि रूल्स बना लेते हैं, कोई बात नहीं। अगर तुम्हें लगता है कि कोई रूल्स ऐड करना चाहिए, तो यहाँ जनरल डिस्कशन में उसको पेस्ट कर सकते हो, मुझे कोई परेशानी नहीं है। अगर वो लगेगा कि हाँ भाई करना चाहिए, तो हम कर देंगे उसे ऐड। बाकी रूल्स वूल्स नाम के होते हैं, तुमको पता है। फिर ये है प्रोजेक्ट आइडियाज। अब देखो हमें जाना है फुल स्टैक डेवलपर की तरफ, है ना। ये हमारा रोड मैप है ऑलरेडी। तो रिएक्ट सीखने के बाद, और जावा ये हमारा स्प्रिंग बूट हो चुका है ऑलरेडी, और माइक्रो सर्विसेज खत्म होने के बाद हमारे पास बचेंगे प्रोजेक्ट्स। तो अभी से चाहो जो भी मन में आ रहा है प्रोजेक्ट्स डालने शुरू कर दो। मेरा आइडियल वे ये था पहले, कि मैं पहले जाऊंगा यूट्यूब पे, और जो प्रोजेक्ट्स ऑलरेडी बने हुए हैं, जिनकी प्लेलिस्ट या जिनकी वीडियोस, उनको फॉलो करते हुए आगे बढ़ाऊंगा, और उनको फॉलो करते हुए कंप्लीट करके बनाऊंगा वो प्रोजेक्ट। उससे क्या होगा, एक तो हमें सिंटैक्स पता लग जाएगा। अभी हमने जैसे पहला प्रोजेक्ट बनाया था ये वाला रिजल्ट ऐप का, तो रिजल्ट ऐप का हमने प्रोजेक्ट बनाया है बिना कुछ जाने। हमने सिर्फ स्प्रिंग बूट देखा, और हमने टेबल्स ज्वाइन कर लिए, मैनी टू मैनी, वन टू मैनी, सब मैपिंग वगैरह करके हमने बना तो दिया। बट वो कितना ऑथेंटिक है बनाना या उसके और तरीके क्या होंगे, तो हम लोग अलग अलग डेवलपर्स जो ऑलरेडी शेयर करते हैं सब, उनको फॉलो करते हुए 2-4 प्रोजेक्ट बनाएंगे और उसके बाद आगे जाएंगे। तो अच्छा खासा ये पूरा सेटअप है, 3-4 महीने का, खूब टाइम लगेगा पर मज़ा आएगा। तो ये सीन है इस पूरे का। ओ बाप रे बाप, बढ़िया बढ़िया बढ़िया, प्रथमेश्वर, प्रवीण, शुभादीप, बढ़िया। ठीक है यार, कम्युनिटी के लिए इतना ही था। बाकी अगर तुम्हें कुछ भी चेंज लगता है या कुछ करना है तो तुम बताते रहो और मैं करता रहूँगा। ठीक है, ये पूरे सारे लिंक्स हैं, तो इसमें ट्राई करना कि इधर का उधर ना हो, जो जिसके लिए बना है चैनल उसी में रहे, तो थोड़ा क्या कहते हैं उसे, नेविगेट करने में इजी होगा हम सबको। बस इतना सा है डिस्कॉर्ड का। अब फिलहाल मैं इसे बंद कर देता हूँ। तो ये हमारी पम्प कोड कम्युनिटी है ना, पम्प कोड कम्युनिटी, थोड़ा कैची नाम है। चैट जीपीटी ने इसको 7/10 का वो दिया है, क्या क्या कहते हैं, रेटिंग। चैट जीपीटी के अकॉर्डिंग नाम कैची है, मज़ा आ रहा है सुनने में, थोड़ा सा फन एलिमेंट है, बट सुन के पता नहीं लग पा रहा है कि कौन सी कोडिंग की बात हो रही है चैट जीपीटी को। हमें कोई फ़र्क नहीं पड़ता उससे, हमें पता है कोडिंग के बारे में ही है। तो ठीक है, ओके। अब जो लोग यहाँ नए हैं, मेरा नाम है अक्षय अग्रवाल। हम लोग जावा की एक जर्नी फॉलो कर रहे हैं, एक फुल स्टैक डेवलपर बनने की एक जर्नी बेसिकली, जिसमें हम लोगों ने बैकएंड डेवलपमेंट यानी जावा से शुरुआत की थी। हमने ऊप्स पढ़ा, डीएसए पढ़ा, उसके बाद कलेक्शंस, एक्सेप्शन हैंडलिंग, मल्टी थ्रेडिंग, स्प्रिंग बूट, स्प्रिंग बूट सिक्योरिटी, और जो लास्ट हमने ख़त्म किया था वो किया था एग्ज़ाम रिजल्ट्स ऐप। तो ये एक ऐप हमने ऑलरेडी बना चुके हैं, एक हमारा मिनी प्रोजेक्ट टाइप ये बन चुका है ऑलरेडी। फ्रंट एंड इसमें नहीं है, हमने बैक एंड से बनाया था। फ्रंट एंड हम जब रिएक्ट सीखेंगे तो उसको यूज़ में लेंगे। फिलहाल इतना काम हम कर चुके हैं। तो अब हम लोग अपना नेक्स्ट टॉपिक शुरू कर रहे हैं, रोड टू माइक्रो सर्विसेज। तो अब हम माइक्रो सर्विसेज की तरफ अपने कदम बढ़ाने शुरू करेंगे। माइक्रो सर्विसेज के पास जाने के जो वीडियोस मैंने देखे उसमें दो थी चीज़ें, एक तो तेलेस्कू और एक ये सजेस्ट किया था एम्बार्क एक्स, है ना। ये वीडियो मैंने देखने की कोशिश करी, देखो 2 घंटे की बची है, मैंने ऑलरेडी शायद कितने 8 साढ़े 8 घंटे की देखी। तो इस वीडियो में 8 घंटे पे जाके हमारा क्या कहते हैं माइक्रो सर्विसेज शुरू होता है एक तरह से। और स्टार्टिंग में पूरा वो फॉलो करते हुए आए हैं, क्या कहते हैं, स्टार्टिंग से एक तरह से स्प्रिंग रिवाइज करने वाली बात हो गई। तो ये 8 घंटे इसमें लगेंगे और उसके बाद आगे बढ़ेंगे हम। दूसरा जो यहाँ है चीज़, उसमें हम लोग डायरेक्टली एक प्रोजेक्ट बनाएंगे, टू डू एप्लीकेशन है या क्या है पता नहीं, क्वेश्चन मल्टीपल चॉइस क्वेश्चंस एप्लीकेशन टाइप, क्विज ऐप एप्लीकेशन, हाँ क्विज ऐप। और इसको फॉलो करते हुए आगे जाएंगे तो काइंड ऑफ मिलेंगे एक ही जगह, बस हो सकता है वहाँ पे चीज़ें कुछ अलग हो, यहाँ पे चीज़ें कुछ अलग हो। तो मैंने सोचा कि हम ना ऑलरेडी एक स्कूल में पढ़ रहे हैं ऐसा मानो, और हमारे टीचर फिक्स है और वो हमें रोज़ पढ़ा रहा है, तो हम बीच में टीचर चेंज नहीं करते हैं ना। ये लास्ट टॉपिक है वैसे भी हमारे जावा का। तो एक बार इसे कंप्लीट कर लेते हैं और उसके बाद हम अलग अलग प्रोजेक्ट्स के थ्रू या अलग अलग चीज़ों के थ्रू, हो सकता है हम उसी वीडियो पे वापस जाके आगे बढ़ें और उससे सीखें। तो इस तरह का कुछ पैटर्न रखेंगे। तो फिलहाल हम जिस टीचर से पढ़ रहे थे हम उसी टीचर से पढ़ते हैं आगे, और एक बार ये कोर्स ख़त्म करते हैं और उसके बाद हम खेलते रहेंगे। तो ठीक है भाई, ये है मेरा बेसिक थॉट प्रोसेस तेलेस्को की वीडियो वापस सुनने का, क्योंकि हम ऑलरेडी रह चुके हैं यहाँ पे। ठीक है तेजस सर, क्या बात है, बढ़िया। अब मैं इसको बंद कर देता हूँ, है ना, कम्युनिटी को। मैं कल देखूंगा वैसे। ठीक है, ठीक है जी, तो हम शुरू कर रहे हैं आज की वीडियो। और ठीक है, ठीक है, स्टार्ट करते हैं।
Welcome back, aliens. My name is Devin Reddy. In this video, we'll talk about microservices. Now, to understand microservices, let's go back to 1970s. That's right, when the computers were new. So in 1970s, we were trying to solve simple problems with the help of computers. Maybe scientific problems, but then they were simple in today's term. Now, after the successful use of computers for the scientific and research purpose, we thought, can we use it for commercial use as well? And that's where in early 90s or late 90s, a lot of people, a lot of companies started using softwares and computers for their internal use. Also, we also got social media websites in early 2000. But now if you try to understand the entire ecosystem, or if you try to understand the world of softwares, everywhere, in fact, everything in the world is happening with the help of softwares. If you want to book a cab, you will use software. If you want to transfer money, you will use software. If you want to buy something online, or if you want to buy something, you will use a software, right? So if everything is done with the help of a software, which we normally call them as applications, what normally happens is we build a particular website. Now that's what we call them. We build a website, and in that particular website, you will be having all the services. Now, when you talk about services, what exactly it means? Now, imagine a shopping website. Example, if you go to Amazon, you get a lot of features there, right? On Amazon, you can basically search for a product. You can buy a product. You can basically add a product to a cart, and then you can buy a product. You can pay for that online. And also, as a seller, I can sell my own devices, or I can sell my own things on Amazon, because it's also a marketplace. So basically, Amazon itself is a huge software which has a lot of different services, right? Now, if you want to build this website by yourself, what you will do is you have a traditional mindset. Of course, one of the best thing about building a software nowadays is we think about creating different modules. So what you do is you break down the entire project into small parts. In fact, that's how we think, right? So if I want to build a website, I will just break down the services into small modules. I will work on one particular module. And also that's what we also suggest, right? So if you have a big team, you can divide your big team into small groups. So let's say if you have 50 people working on one big project, you can have 5 different teams of 10, or maybe 10 different teams of 5 members. And then these people will work on one particular feature, right? And that's how you can build this amazing website like Amazon or Amazon.com to buy something. Now, the thing is, the approach is actually coming from the software development field. Now, when you build a normal software, what is the tendency? So we have a software which works on a desktop. In fact, when I started my career, I started in that zone. You can just write an application which works on a particular machine, right? So what you do is you structure your entire application for one device. Now, that's what we do in the web world as well. Even if you have multiple teams, they are working on different services, they are still one package, right? So maybe in Java or in other languages, what you do is you create a package, right? You create, let's say in Java, we create a var file or a jar file. You will put all the services in this particular var file, and then you will deploy this on a cloud or on any server. The problem is you have a lot of services here on one system. So let's talk about some advantages of doing this. The advantage of doing this type of architecture, which we normally call them as monolithic application or monolithic architecture, where you have everything in one place, all the services, right? Of course, they are designed by other members. You can simply group them. You can form a particular package and you can deploy it. So the good thing is you know what is happening with the application. What are the drawbacks? There are multiple drawbacks with this type of architecture. The first one is team dependencies. So let's say if all your team, your 10 teams are working together to make all these features, they have to actually dependent on each other. They should know when you are going to go for the next release, right? So of course, with every release, you go for a version. So you have to specify, okay, I got a new feature, but let me know when I can push this feature in the product so that we can deploy the entire project. The second one is the scalability. Let's say if we talk about Amazon itself, in fact, we can take this example or we can take this concept for multiple examples, multiple domains. But if you stick to Amazon here, let's say there's a sale going on. Now, if you know that tomorrow there will be a huge sale, maybe for some festival, some other event, what do you think, which of the services will be needed scalability here? In the monolithic application, what happens is if you know that there's a sale going on or there will be sale happening next week, what you will do is you will scale your application in multiple systems, right? Maybe you will try to do vertical scaling by adding more servers or more RAM power, or you can do the horizontal scaling. So basically you will have the same application and having multiple instances of them. See, in terms of sale, it's not like you will get new users or you will get a lot of new users, you will get a lot of new sellers. What you will get is more searches. You will get more payments. So instead of scaling the entire application, don't you think we should be scaling only the small modules there? So that's what we want, right? We want to use this particular service. So instead of scaling the entire monolithic application, we should be able to scale that individual services. Next one, what if you have a big application and if you think we will build this application using as a one monolithic application, The thing is, you have to stick to one technology. Maybe if you're using Java for the entire application, you have to stick to Java.
Yep.
Even if you have a new team who says, okay, I want to work on Node.js, they can't, because you are building one big application which will create one particular package which will go to one particular server. What you can do is, if you have a different services here, you can actually create different services using different technologies, right? So that's one of the advantage we want, and that can be done with the help of microservices. So each service which I'm talking about here, they are called microservices. The advantage is, if you have 10 teams, they can divide the entire project into small services. One thing to remember here, each service here should be self-contained. They should be able to deploy it separately, and also they should be scaled separately. They should not be dependent on some other services. So each service here will be called microservices. Now, since they are microservices, we can create them in any technology we want. So one service can be done with Java, second service can be done with Node.js. And now, since there are multiple services, you can scale them the way you want. Maybe if you have 10 services, I want to take this fifth and sixth service, and I want, let's say, 10 instances of them. I want the second service to have 5 instances. So I can scale based on the service requirement, not for the entire application. And also, since they are separate services, even if some service goes down, it will not affect the entire application. Now, in terms of monolithic application, if you make one change, it is not working, it will crash the entire application. That's not the case with microservices. So basically, what is microservice? They are individual services which are self-contained. They can run as an individual service. And maybe let's say if I want to go to Amazon, if I say I want to search for the products, that's one service. I want to create a new account, that's one service. I want to sell a particular product, that's one service. So these are your microservices. Now everything looks good on paper, right? We are saying that microservices are great. Do we have any challenges there? The thing is, yes. Now since we have multiple services, how these services will communicate? It's not like they can't, but then it's difficult to configure them, okay? And you will be doing that only once. You have to use service discoveries, you have to use API gateway, which will stand in front of all the services. And you will be also having some resilience system in between. What if some service failed? Do we have fail support there? And creating a microservice is not just about writing code, okay? It's also about creating the architecture before you write a single line of code. How do you design your system? How do you create those services? That's also important. And if you don't design your microservices properly, ultimately you are creating a worst system of monolithic application. Now, one of the questions might be how these services communicate. So they basically uses HTTP request or response to communicate between each other. Of course, they will be having endpoints to communicate. And also we have to also think about security, because now since you have different services, if a customer sends a request, which services you have to go to, and does that particular user has access to do that. So that's the challenges of microservices, but it's an awesome thing. Big companies, they are using microservices on big level. So that's it.
ठीक है cool. किसी को डाउट तो नहीं है यहाँ तक किसी चीज़ पे? आई एम प्रीटी क्लियर अबाउट अभी तक. रुको मैं एक बार अपनी भाषा में बोल देता हूँ. एक बार मैं भी आगे कभी देखूंगा तो इजी हो जाएगा मेरे लिए भी. रुको चलते हैं नोट स्क्रीन पे जल्दी से. और हाँ जी ठीक है. जितना पढ़ा है थोड़ा सा थ्योरी सबसे ज़रूरी होती है. थ्योरी ये बहुत बाद में समझ में आता है जब एप्लीकेशन क्रैश करती है 2-4 बार. ठीक है, तो सबसे पहले हमारे पास 2 तरह की अप्रोचेस हैं या 2 तरह के ऐप्स हैं. बहुत बढ़िया. एक है हमारे पास मोनोलिथिक और एक है हमारे पास माइक्रो सर्विसेज. ठीक है, पूरा नहीं लिख रहा मैं. है सीन. अब देखो सीन क्या है. यहाँ पे हम लोग मोनोलिथिक में एक एप्लीकेशन बनाते हैं, उसके अंदर मल्टीपल मॉड्यूल्स होते हैं. ठीक है, अमेज़ॉन का एग्जांपल लिया है. वैसे अमेज़ॉन की एक मस्त चीज़ बताता हूँ तुम्हें. अमेज़ॉन हमारा मोनोलिथिक से माइक्रो सर्विसेज पे शिफ्ट हुआ था. फिर उसके बाद माइक्रो सर्विसेज नहीं संभला तो वो वापस से मोनोलिथिक पे शिफ्ट हुआ था. या तो नहीं संभला सही रीज़न नहीं है. रीज़न ये था कि ज़रूरत नहीं थी अमेज़ॉन को, तो वो वापस से मोनोलिथिक पे शिफ्ट हुआ था. आई थिंक 1 या 2 साल पुरानी बात है, ये मुझे एग्जैक्ट याद नहीं है, बट ये न्यूज़ में आया था बहुत बड़ा कि माइक्रो सर्विसेज बूम पे है. और उसके बाद भी अमेज़न जैसा एक बड़ा जायंट मतलब मोनोलिथिक पे मूव कर रहा है। तो कई बार ज़रूरत नहीं होती हमारी एप्लीकेशंस को माइक्रो सर्विसेज पे मूव करने की। हमारी हर एक एप्लीकेशन को माइक्रो सर्विसेज पे मूव करने की ज़रूरत नहीं है। तो ठीक है, अमेजोन का एग्जांपल, इसके पास क्या है, एक सर्च है, एक हमारे पास कैटेगरी है, एक अकाउंट क्रिएशन है, एक पेमेंट है, बस इतना रख लेते हैं, काफ़ी है। और यहाँ माइक्रो सर्विसेज, तो जो इसके डिफरेंट मॉड्यूल्स हैं वो यहाँ पे अलग अलग माइक्रो सर्विसेज होंगे, है ना। तो माइक्रो सर्विसेज किसका, सर्च का अलग, तो इसकी अलग टीम, इसका अलग सर्वर, इसका अलग सब कुछ। तो ये हो गई टीम वन, बेसिकली मैनेज कर रही है। फिर दूसरा आ गया हमारा कैटलॉग, हमने रख लिया था, तो कैटलॉग का हमारे पास टीम टू मैनेज करेगी। कैटलॉग के बाद अकाउंट से रिलेटेड चीज़ें टीम थ्री मैनेज करेगी। और फिर पेमेंट से रिलेटेड चीज़ें टीम फोर मैनेज करेगी। तो ये अलग अलग बने हुए हैं और आपस में उसी तरह कनेक्ट होते हैं जिस तरह हम कोई थर्ड एपीआई कनेक्ट करते हैं, या अभी वो हमें पता नहीं है, बट ये बेसिकली एचटीटीपी के थ्रू कनेक्ट होंगे। तो जिस तरह से हम अपने एंड पॉइंट्स बनाते हैं, हर एक सर्विस के पास अपने एंड पॉइंट्स होंगे, और अ, और हम उन एंड पॉइंट्स को बेसिकली हर एक माइक्रो सर्विस से आपस में कॉल करा के कम्युनिकेशन बैठाएंगे। इस चीज़ को शायद माइक्रो सर्विसेज में ऑर्केस्ट्रा बोलते हैं पूरा, कि सारे अलग अलग इंस्ट्रूमेंट्स हैं और उसको अब एक साथ प्ले कर रहे हैं काइंड ऑफ। अब चैलेंजेस ऑफ मोनोलिथिक क्या है, कि ये लैंग्वेज डिपेंडेंट है काइंड ऑफ। लैंग्वेज डिपेंडेंट होना मोनोलिथिक एप्लीकेशन की सबसे बड़ा चैलेंज है। मान लो आज हम जावा सीख रहे हैं, तो हम बहुत श्योर है कि हमें जावा में ये सब करना है, वो सब करना है। अभी भी हमारे जो डेटा साइंस से रिलेटेड चीज़ें हैं, या हम बोलें एआई से रिलेटेड चीज़ें हैं, उसमें किसका डोमिनेंस है, पाइथन का, करेक्ट। तो जहाँ पे हमको रिपोर्ट जनरेशन के काम करने हैं, या हमें कोई यूज़र बिहेवियर पैटर्न पकड़ना है, या फिर हमें देखना है कुछ कुछ भी इस तरह की चीज़ कि एनालिटिक्स से रिलेटेड, या फिर क्या हो सकता है पाइथन का, डेटा साइंस का और यूज़। ये भी हो सकता है कि हम कोई फ्यूचर प्रोडक्ट लॉन्च करेंगे, उससे पहले ही हमको पता लग जाए कि वो प्रोडक्ट कैसा परफॉर्म करेगा मार्केट में बेस्ड ऑन द प्रीवियस डेटा और वो सब। जो पूरा डेटा साइंस का पार्ट है बहुत अच्छा पार्ट है, बट उतना अच्छे से आई थिंक पाइथन का सबसे बड़ा प्लस पॉइंट ये है कि इसने पकड़ बहुत अच्छी पकड़ी है इस वाले एरिया में, एआई में, प्लस अपना ये डेटा साइंस में। तो अगर हमें यहाँ पे इम्प्लीमेंट करना है अमेजोन, या हमारी कोई एप्लीकेशन है, अमेजोन तो बड़ा नाम हो गया, हमारी कोई एप्लीकेशन ले लेते हैं, क्या नाम रखा है हमने कम्युनिटी का, पम्प कोड की। मान लो हम लोग एप्लीकेशन बना रहे हैं, ई कॉमर्स बना दी हमने, इसे आगे जाके मिल मिला के चीज़ें बेच रहे हैं, जिसके घर में जो मिल जा रहा है बेच रहे हैं। तो अगर हमें कुछ भी चेंज करना है आगे जाके, या हमें ए आई डी एस ये सब यूज़ करना है, तो अब हमें जावा पे ही करना पड़ेगा। ये है एक बहुत बड़ा डिसएडवांटेज, है ना, कि हमें जावा पे ही यूज़ करना पड़ेगा। एक डिसएडवांटेज यहाँ पे, हम उस मॉड्यूल का, उस पर्टिकुलर मॉड्यूल का एक सेक्शन बना सकते हैं, और वो दे देंगे हम, या तो खुद पाइथन सीख के कर लेंगे, या हम वो दे देंगे पाइथन टीम को कि भाई ये बना के दो ज़रा, और ये वो बना के देंगे। एट द एंड क्या है, हर चीज़ एट द एंड तो एंड पॉइंट्स ही हैं जिसको हम कॉल करेंगे। पाइथन में अगर कोई कोड लिखा होगा और वो हमारे पास रिव्यू के लिए आएगा, तो ऐसा तो है नहीं कि हम उसे रिव्यू नहीं कर पाएंगे। हम देख सकते हैं कि भाई इसने नेस्टेड लूप लगा दिए, या कोई ख़राब कोड हो गया, या कुछ इधर उधर दिख रहा है, या कुछ समझ नहीं आ रहा, तो हम उसका क्या कहते हैं, पीआर मर्ज करने से पहले हम एक डेमो ले सकते हैं, या एक पीयर काइंड ऑफ टेस्टिंग कर सकते हैं कि भाई चला के दिखाओ, डेमो, डेमो ही बोलते हैं उसे, ओके कूल है। तो ये एक चैलेंज, बहुत बड़ा चैलेंज है ना। अभी एक मस्त चीज़ हो रही है हमारा ना, स्प्रिंग स्प्रिंग एआई लेके आया है, थोड़ा अनरिलेटेड टॉपिक, स्प्रिंग एआई की तरफ मूव कर रहा है। तो मैं काफ़ी एक्साइटेड हूँ इसके लिए, अगर ये चल गया, क्योंकि जावा हमारा अच्छा खासा शेयर होल्ड करता है मार्केट में, और अगर डी एस या एआई की तरफ जावा चला गया, तो आई थिंक थोड़ा मस्त बदलाव आ जाएगा। तो हम लोगों को शायद पाइथन की तरफ जाने की ज़रूरत नहीं पड़ेगी और जावा ओवरटेक कर ले। बहुत 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 फारफेच सेंटेंस है ये, बहुत फारफेच क्लेम क्लेम लग रहा है अभी ये, पर देखते हैं। तो एक चैलेंज तो हो गया हमारा कि वो लैंग्वेज डिपेंडेंट है। ठीक है, ये हटा देता हूँ मैं। नेक्स्ट नेक्स्ट जो सबसे बड़ा चैलेंज है वो ये है कि हमारी एंटायर एप्लीकेशन हमें मैनेज करनी पड़ती है एज अ वन। चलता है ये बड़े अच्छे से। क्या चलता है बड़े अच्छे से अंकित यार? स्प्रिंग एआई की बात कर रहे हो क्या? एज वन एंटायर एप्लीकेशन एक है हमारी। यहाँ पे हमारे पास अलग अलग एप्लीकेशन है। ये हमारी ऐप वन है, ये हमारी ऐप टू है, ये हमारी ऐप थ्री है, ऐप फोर है ना? और ये ऐप फाइव, मान लो फाइव हमने बना दिया। यहाँ पे हमारे पास ये पूरी एक एप्लीकेशन है। तो एक एप्लीकेशन जब होती है तो उसकी डिपेंडेंसी बहुत ज़्यादा होती है दूसरी मॉड्यूल्स पे। मतलब अगर हमारे इस पूरे प्रोग्राम में स्प्रिंग एआई चलता है बड़े अच्छे से, अरे नाइस यार, स्प्रिंग एआई मस्त। मैंने अभी तक देखा नहीं है। मैं ये सब कंप्लीट हो हमारा माइक्रो सर्विसेज फिर चलेंगे स्प्रिंग एआई की तरफ, देखते हैं जरा क्या चीज़ है। मैंने देखा नहीं पर मैंने सुना और मेरे को काफ़ी खुशी हुई कि देखते हैं उसमें क्या है। हालांकि एआई में मैं बहुत इंटरेस्टेड तो नहीं हूँ, बट फिर भी देखने लायक चीज़ तो हो गई है। बढ़िया। ओके, एक मिनट रुको। बचा ले रहा हूँ ना मैं हर बार। हम्म। हाँ हाँ। ओके जी। नू नू बोल रहा हूँ। सेकंड चीज़ क्या थी कि एंटायर एप्लीकेशन एक साथ एक सिस्टम पे चल रही है। तो हम लोग अगर चाहें इसमें नया मॉड्यूल ऐड करना, पहला नया मॉड्यूल ऐड करना, या फिर कोई अपडेट करना है मॉड्यूल हमें। जब भी कुछ अपडेट होता है मॉड्यूल में तो ऐसा मान के चलो कि एरर आती ही आती है, चाहे वो एप्लीकेशन हमारे कोई भी एप्लीकेशन दुनिया में ऐसी नहीं है जिसमें एरर ना हो। अभी बस वो मिली नहीं है, या मिली है तो उनकी कोर टीम को मिली है जो वो सॉल्व कर देते हैं हमें मिलने से पहले। तो इस तरह से पूरा एनवायरनमेंट चलता है। तुम सब जॉब करते हो ऑलरेडी, तुमको ये सब चीज़ें पता हैं। न्यू मॉड्यूल या कोई मॉड्यूल अपडेट करना है, या कोई मॉड्यूल मान लो माइग्रेट करना है। माइग्रेट यहाँ पे तो हो ही नहीं पाएगा। यहाँ पे तो हमें पूरा का पूरा एप्लीकेशन माइग्रेट करना पड़ेगा। यहाँ पे मान लो जैसे अभी हमने बात करी कि हमारे एआई वाली चीज़ों पे हमारा धीरे धीरे स्प्रिंग आ रहा है और अच्छे से काम कर रहा है। तो हो सकता है कि आज की डेट में हम यहाँ पे पाइथन यूज़ कर रहे हो, बट आगे जाके हम इसको चेंज कर लेंगे जावा में। तो हमारी पूरी एप्लीकेशन वैसी की वैसी रही, सिर्फ हमारी ये एक टीम जो काम करेगी वो इसको जावा में शिफ्ट कर देगी, है ना? तो ये फ़ायदा है हमारे माइक्रो सर्विसेज का। दो फायदे कुल मिला के, और भी होंगे बहुत सारे, फिलहाल दो देखे कि एक लैंग्वेज डिपेंडेंसी इसने हैंडल कर दिया हमारा, और दूसरा फ़ायदा कि हमारी एप्लीकेशन चंक्स में बट गई। और चंक्स में बटने का मतलब सिर्फ एप्लीकेशन नहीं, हमारी टीम्स भी चंक्स में बट गई। तो हम इस पूरे जैसे पूरे इकोसिस्टम के एक चीज़ पे काम कर रहे होंगे, और एक अच्छा इकोसिस्टम बिल्ड हो गया तो हम अपने अपने रिलीजेस कर सकते हैं। रिलीज का क्या पंगा था? रिलीज का पंगा ये है कि अभी यहाँ पे मोनोलिथिक में जो रिलीज होता है ये पूरी एंटायर एप्लीकेशन का होता है। जैसे वर्जन वन आई है एप्लीकेशन की, या वर्जन इसके अंदर कुछ रख देते हैं, बग फिक्सिंग हुई है या नया फीचर इम्प्लीमेंट हुआ है, तो उस तरह से ऐसा कुछ वर्जन पॉइंट करके बना देते हैं। तो किसी भी एप्लीकेशन का ऐसे ही चलता है। तो इस तरह का ये एक रहता है। बट यहाँ पे हमारे हर एक मॉड्यूल का अपना अपना वर्जन हो सकता है ना? जिस तरह से हम यहाँ पे डिपेंडेंसीज यूज कर रहे थे कौन से वर्जन की, स्प्रिंग बूट वाली, तो वो एक अच्छा सिंक बैठा देगा चीज़ों का। तो ये है। ठीक है जी। तो यहाँ बात हो गई हमारी पहली वीडियो की। ठीक है, ठीक है, ठीक है। आगे बढ़ते हैं। रुको मैं स्क्रीन चेंज कर लेता हूँ। अभी भी कुछ डाउट हो अगर इस टॉपिक पे तो पूछना। और अब तो कम्युनिटी भी है, वहाँ भी पूछ सकते हो।
Welcome back, aliens. My name is Navin Reddy, and in this video, we'll talk about cloud computing.
Okay.
And we know about cloud, right? Oh, not that one, but the cloud basically means the group of
बारिश होगी तो डेटा गीला हो जाएगा क्या?
computers on a network. I know, that sounds simple now, right? Now, basically, why we have this concept of cloud computing. Now, think about this. If you go back in the earlier days of software development and web application, what we do is, example, let's say if you want to make a website, what you do is you use certain technologies like HTML, CSS, JavaScript, using which you can make a static website. Of course, you can use JavaScript to build backend as well. But just to keep it simple, let's say if you want to make a static website, you can build that with the help of HTML, CSS, and JavaScript, and then you can run that on your machine. And that's why when you run it, you will see a URL on the top, right? Now, basically, if you want to make a dynamic website, let's say if you want to add a backend to it, it can be done with the help of JavaScript, PHP, Java, C#. There are multiple options there. But let's say when you build a backend as well, you need to run a server, which we call a web server. Now, this web server is running on your machine. Of course, it also needs an IP address. And by default, if you're running on your own machine, you use something called a local host. That's your own machine, right? And then it works on your machine. But then when you're building an application or a website, you want the world to use it. You're not doing it for yourself, right? Now, in this case, if you want the entire world to use your machine, that's not possible because the website is hosted on your machine and you don't have a public IP address. What you get from your router is a private address. And if you want the world to access your website, you need to get a public address. And let's say you bought a public address. And now you can basically use a public IP address for your machine. So let's say I have this machine here, and in this machine, I'll be having the web server installed. And then I also have a public address. Now you can give this public address to the world and they can use it. Oh, you'll be saying, okay, they cannot remember your public IP address. That's fine. You can get a domain name. Let's say you got a domain name as telesco.com. So instead of using a public address, now you also have a domain name. But the thing is, the application or the web application is hosted on your laptop. And of course, you want this website to be accessed 24/7 into 365 days. You don't want this website to go down. But unfortunately, this is a laptop. And let's say if I forgot to put a charger, which normally people do, the laptop will shut down. And then people will not be able to access your website. Maybe I'm using a charger and then Windows says, I want to update myself. And then, right, you can't stop it. So basically, your website is down. Maybe your laptop is not working anymore. Maybe you spilled a water on your keyboard and now it's damaged. Now, basically, laptop is not a good option, right? And also there's one more problem with laptop is the computing power. Let's say you got millions of users and they are hitting your website. And now this laptop is not capable to service all the customers. And that's why you need to get a good hardware. Now, in the earlier days, we used to go to the market, the hardware shop, or the hardware market where you can get all the devices to build a good server. Basically, you need a good CPU, you need a good RAM. Okay, I'm not talking about the CPUs which you use in a normal laptop. I'm talking about a server CPU, a good amount of RAM. Your 16 GB or 8 GB RAM will not be enough. You also need a good storage. Maybe you want users to create an account, right? And they want to update their details on the website. So of course, it will consume a lot of memory. And then you have to build a big server. And let's say you invested around 1 million.
Every developer needs this Chrome extension. Daily.
That's a big amount. So let's say invested around $100,000 to build a big server which can cater to the millions of users. And now everything is working. Now, since that's not a laptop, so it will have a good computing power, and you have to make sure that you install a good OS which will not go on update frequently. And also you have to provide security. Now, in the earlier days, you have to do everything by yourself. Get a room, set up the machines and make sure that it is up and running. You need a good internet speed. You need electricity power continuously. You need a cooling system to cool the entire environment, because I'm talking about a server, not a laptop. Even if you play a small game on your laptop, you know what I'm talking about, right? It will create a lot of heat. So you have to manage everything. And also you need an admin to manage that machine. That's right. A human is also involved to maintain the entire server. And that particular human need to be properly skilled in terms of configuration, in terms of security as well, because your user data is there in that machine. So that's one thing. This is a huge investment to start with. Imagine you're a startup now, and then to start a company, you need to invest a lot of money just to set up the system. And you don't want to do that, right? Now, what's a solution here? In fact, before going for solution, we have few more problems. Let's say you have this system ready and you have your e-commerce website, and now everything is working well because you're getting around 1,000, 2,000 or 10,000 users every day. But let's say tomorrow there's a sale. So a lot of new products will be going on sale. Maybe you are selling an iPhone for 50% discount. Okay, I want to buy that. But the thing is, a lot of users will be coming to that website. Imagine, let's say you're selling a pen drive at 8 a.m. for 1 rupee. Imagine the number of users coming to their website. At this point, your server will go down. So before going down, what you will do is you will go to the market, you will buy a new server with the same cost. And the thing is, everything is working now, and then the sale is over. Now you don't have that much of users, and we have extra server lying there doing nothing. So you wasted your money there, right? Now, to solve this problem, what you can do is you can, instead of doing everything by yourself, buying a computer, maintaining it, getting a person who can manage everything, basically an admin, and also a person for the security, you can say, okay, I don't want to do this. Let me just hand these things to some experts. Now, this is where there are companies who provide you this service. They say, okay, you don't have to buy server by yourself. You don't have to manage. You give us the money. We will buy the servers. We will buy everything, and we will manage it. Still, you have to do the initial investment. You have to buy those servers, which is not with you. They are managing it. So that was one solution. But then again, that was not optimized. In fact, these people, they buy the server and they create multiple virtual machines on the same server, and they cater to different clients. Maybe you can say multi-tenant type of stuff, where we don't have one customer, we have multiple customers on the same server. But still, you are investing, and still they still have only one machine. What if something goes wrong? What if there is a network issue? What if there's a power failure? The entire website goes down. And this is where we thought, okay, let's not use one machine. Let's use multiple machines at multiple locations, because your users are not from one region. They are from India, US, Europe, Middle East. They are coming from everywhere. And if you want to cater to all the customers, you need servers in each location. That will reduce the latency, right? Now, this is where we are, instead of going for one server, what if we can go for multiple servers? They are connected and provide you the solution. Example, let's say even if you want to add, let's say 5 numbers. So you can send that request to one server. Hey, I want to add 5 numbers. One server can do it, or multiple servers come together to solve that problem. And that's what happens when you search something on Google. When you search, it's not like only one server is involved. There are multiple servers working together to give you that result instantly. So basically, you need multiple servers, and when you connect multiple servers, that's where the new term arrives, which is cloud. So cloud, what is cloud basically? Cloud is a combination of multiple servers which are there, which you're not handling, someone else is doing for you. Now, who is doing it? We have multiple service providers. You might have heard about Amazon, AWS, we got Microsoft, Azure, we got Google Cloud. We have Red Hat also in this market. We also have IBM. Everyone is now in the cloud market, and they say, you don't have to buy the servers. We have servers. You just pay per use. That's right. You don't have to do any investment. Let's say you're a startup and you don't have that much of money. You don't even have customers now. And every day you get new customers. What you can do is you can say, hey, Amazon, I have, let's say, 1,000 users per day. Give me a computing power only for those users. And the moment I get more users, just scale it. Give me 2 instances. Give me a bigger instance. That is elastic scaling, which we call. In fact, they also have something called elastic cloud computing, which is the resources expands on your requirement. That's the power of cloud. One of the best thing is you're not managing it, and they give you uptime, which is almost 100%, not exactly 100%, but they give you almost 100% uptime, and you're not managing anything. Now the question arises, have we used any cloud service yet? If you are using internet, you are basically using cloud by default. If you use Gmail, that's a cloud service. If you use Google Docs, that's a cloud service. If you play game online, that's a cloud service. Everything nowadays is a cloud service, and by default, we are using them, right? Now, in the cloud as well, depending upon different users, we have different types. We have different service models. Example, let's say initially you had everything with you, that's on premise, where you have the hardware. So basically you have to get the hardware, basically you have to get the networking, you have to get the storage, you have to also install some OS, you have to also install the runtimes and containers. Let's say if you talk about software development, we use something called containers now. So you have to install the runtime, you have to install the
यहाँ जोड़ रही थी चीजें. ओके ओके.
about software development, we use something called containers now. So you have to install the runtime, you have to install the containers, and on top of that, you have to install your application, which will have certain methods, certain classes. You have to manage everything that's on premise. Now, let's say you want to use some cloud service where you say, I am okay to manage the software layers and OS, but I don't want to manage the hardwares. Now, this is where IaaS comes into picture, in which basically they give you the hardware, networking and storage. Everything else is yours. So which operating system you have to install is dependent upon you.
As a service, IaaS क्या internet as a service. Indian audit. अरे भाई. Cloud computing. Infrastructure as a service. Okay.
You can decide, I want to go with this OS, I want to go with this runtime, I want to go with this containers. That's my application, that's my function, everything done by you, except the data centers or the network or the hardware or the networking stuff. But let's say you don't want to even manage the OS. What you want to manage is the containers. Example, let's say if you want to work with Docker or Kubernetes. Now in this case, you can say, I have the application, I have the runtime, I also have the containers. I want you to give me the operating systems which will support containers. That is your CAS, which is container as a service. But let's say you want to go one level up. You don't even want to manage the runtimes. In this case, they also offer you something called a PaaS, which is platform as a service. What you can do is, you get everything basically. You get the hardware, you get the networking, you get the OS, you also get the runtime. You just have to build the application and deploy it. So it basically provides you a runtime where you can build the application. Now we can go one step forward. There's a concept of serverless computing. Now it sounds like serverless, but there is servers. Of course, we cannot achieve something without servers, right? So serverless, they have servers. It's just that you don't have to worry about any server. You say, I have this function or I have this particular module. I just want to run it. Now, if you can get into a subset of it, there's something called function as a service, where you create a function and you say, I just want to run this function. I don't care where it is running. I just want to run this. Also, what if you want to scale your function? Let's say you have 10 functions, out of which you have 2 functions which you think will need more computing power. You can scale them, that particular 2 functions. That is function as a service. And then we have the next layer which we use as a normal user, which is SaaS, which is software as a service. Example, let's say you want to store photos. You don't have to build your own photo library on the cloud. You get Google Photos. What if you want to type on an editor, or maybe you want to type code? You don't have to install software on your machine or on the cloud service. You get online editors where you can build the application, right? So those are your SaaS platform. Even Gmail, Google Docs, everything which you use on cloud is SaaS, which is software as a service. Now, as a developer, we normally focus more on the PaaS, which is platform as a service, or CaaS, which is container as a service. And it looks cool, right? The cloud services looks cool. And you will be thinking, okay, this is good. Every company should be using cloud. They are using clouds, and most of the companies are actually moving from on-premise to cloud services. But the problem is, if you talk about cloud, let's say AWS. Now it's a public cloud, which simply means if you host your application on a public cloud, Amazon is managing it, right? And they are basically sharing the hardware with the other tenants as well, other people as well. Now, in this case, there are some issues in terms of security. Of course, in terms of cost, it is less because you're using a public cloud and it is shared by different people. But what about security? The data which you get from your customers are getting stored on these servers. Normal data, that's fine. But what if there's some financial data? What if there's a personal data? What if there are some data which no one should know? But let's say as a company, you're storing your customer data on a cloud service, which is third party. There is a kind of risk here. Now, by default, all the servers are public clouds, right? So these are accessible for anyone. It's not like they can hack your data, but it is hackable, right? How can you trust it? Also, there are some regulations which you have to follow from the government. And that's where we have some issues with the public clouds. What's the solution? You can create something called a private cloud inside your company's wall. So basically, you have a cloud which is a private cloud for your own company. So you'll be having multiple data centers. Someone will be managing it, but you have a control on your private cloud. And all your customer data will be stored on private cloud. Advantage, safety. Drawbacks, cost. Because now you have to manage everything. So what if you can get a solution between these two? And that's where we have something called a hybrid cloud. So what you do here is, every company will have data from the customer. Some data is private. You have to maintain the privacy there. And some data is okay to shift to public clouds. So you will be using some services of public cloud and some from private cloud. This is the hybrid cloud. And most of the companies are using it. In fact, you might have seen this. Companies are moving from on-premise to the cloud. But there are few companies, they are coming back. They're coming from cloud to on-premise because they thought cloud is great. But looking at the cost now, sometimes if you don't build your application properly, or there are some cloud services which are not that optimal, you might get surprised by the billing they charge you for that particular service. So yeah, that's about cloud computing. So what simply means is, instead of doing computing on your own machine or your own server, you can give this computing power to some third party, some cloud providers. You simply build an application, deploy on the cloud, and they will do the computing for you. You just have to pay on the go. So that's it.
ठीक है, मस्त. लाइक कर देते हैं वीडियो. जो वीडियो देखें उसे लाइक कर देना चाहिए, राइट? थोड़ा अच्छा रहता है. ये क्या पढ़ रहे हैं अब हम? ब्लू ग्रीन डिप्लॉयमेंट. ठीक है, देखो, अगर ये सब चीज़ें हैं इस लिस्ट में तो इसका मतलब आगे कहीं ना कहीं लिंक मिलेगा, है ना? तो इसलिए हम बस देख रहे हैं. हालांकि थ्योरी देखना थोड़ा बोरिंग हो सकता है एट टाइम्स, बट जरूरी है भाई.
Welcome back, aliens. My name is Navin Reddy, and in this video we'll talk about blue-green deployment. Now basically, if you have ever observed, there are a lot of applications or services which we use. It says that they are going for the maintenance at this time, and most of the time the maintenance of that particular website or web application happens at the night time. Now think about those developers who are sitting there waiting for the night time to deploy the application, or maybe they can schedule the updates, but still they have to be there because what if something goes wrong? The thing is, why these updates are happening at the night time is because they have less users. Of course, it depends upon the region as well. Example, if I'm doing a update for an application which will be used in India, I will be doing that update at the night time in India because you'll be having less users. Now what happens is, every time you have a new feature, so let's say you got an application which is, let's say, version 2.5, and now you want to release version 3.0. Now at this point, your running server, the server which is live, need to be shut down and it has to be upgraded. And sometimes it takes time, right, to upgrade your entire application. Maybe, let's say, 2 seconds or 10 minutes or 1 hour. Now, in that particular time, the users will not be able to use your application. And that's why it happens at the night time, right? But think about the people who are behind these updates. They have to be there. Now you might be thinking, okay, what's the big issue? We will be doing updates once in a year or once in 6 months. And if the system goes down for, let's say, 1 hour, that's fine. We'll update our users. See, that's the old technique, right? Nowadays, what we want is, instead of updating the service after few months, we do updates in a week now, right? So that's the agile way of doing stuff, where you want to get the customer feedback.
तुम लोग हो गए स्प्रिंट में ऑलरेडी? स्प्रिंट ही बोलते हैं ना, स्प्रिंट चलता है ना हम लोगों का 2-2 वीक्स का.
Back instantly. Now when you want a customer feedback, of course you want to push the new features, and for that purpose you will be updating your software frequently. And imagine going 1 hour off in a week, your user will not be satisfied with that. So there are two issues. First is the major one, which is where your customers will face an outage. Basically, they will not be able to use your application for that particular time. And second issue is the developers, of course, or the ops team. They have to sit there. Now, even if you deployed your new version from 2.5 to 3.0, what if something goes wrong? Of course, you tested it properly. So you tested the entire project, entire package, internally, privately, and everything was working there. Suddenly, the moment you make it public, it is not working. Again, you have to go back to the older version. Again, you have to face the outages. Now, what's the solution for this? The solution is the blue-green deployment. Now, do we really have to paint your application with blue color or green color? Not exactly. This is just a term. They also use terms like red, black, or having a secondary instance. Doesn't matter. Name doesn't matter. What's important is, this concept simply means you'll be having 2 running instances at the same time. That's right, 2 running instance. Now in this 2 instance, one will be called a blue server, or second will be called a green server, or maybe a blue instance or a green instance. Now at one point, only one instance will be live, okay? So even if you have 2 instances running, and even if both are running, but then only one will be live for the public. So let's say in this case you have blue. So all the users are actually using this blue instance, right? Now in this blue instance, you are doing all the operations. In fact, this is responsible to accept the user request, respond to it, or maybe this is connected to some other servers as well, or maybe some to a database. Now, parallelly, you'll be also having a green server. Now, what's the use of this green server? Now, this is there sitting idle, doing nothing. Now, as a DevOps team or as a developer team or ops team, you want to push a new update from 2.5 to 3.0. Of course, you will not be doing that on a running server because that's running, right? So what you will do is you will do the update in the green server or the green instance. And you will say, okay, I have the new package, everything is tested. Let's deploy that on this green one. Now, the moment you upgrade your green instance to 3.0 and you think it's ready to go live now, you will gradually move your users from the blue instance to the green instance.
Rohit, hi Rohit, hello bro, how are you yaar?
Of course, you will not be moving everyone because what if something goes wrong? So maybe do it gradually. At least if something goes wrong, least users will be affected. So you are gradually moving your users from blue to green, and now once everyone is moved to green instance, see at this point when they are moving, both instances are live. But the moment you got all the users on the green instance, now your blue instance can go to idle state. You don't have to destroy it because in a blue-green deployment, you do need 2 servers running or 2 instances running. Now, what is the role of blue one here? So blue one is there sitting idle. Maybe you can use it as a recovery server. What if something goes wrong with the green server? At that point, you can say, okay, we do have a blue instance and just route all the traffic to blue. And once you are confirmed that the third instance is running perfectly, you can just also upgrade your blue one to 3.0, and then again you're not using 3.0 blue version, but it's there. Now what if after some time you got a new updates? Now since we are into a phase where you want to upgrade your services continuously,
हाँ माइक्रोसर्विस प्रारंभ कर दी नाइस हाँ यार माइक्रोसर्विसेज स्टार्ट हो चुके हैं ऑल्सो एक और अपडेट है रोहित यार चैनल पे जाके डिस्कॉर्ड देखना डिस्कॉर्ड हमने अपना लाइव कर दिया तो उसको ज्वाइन कर सकते हो
right? There was a time when you used to provide the updates monthly, but now because of this new service or new feedback from the customers, we push the updates continuously. Now at this point, let's say you got 3.1 version. Now where you will update it? On the green one? No, you have to do that on the blue. Now the same process which went for the green one will go for the blue one as well. So even in the blue one, you will push the update, and then again, it's still private. Once it is 3.1, it is still private. And now once you think everything is tested well, it's time to go live. What you will do is you will gradually move your users from the green instance to the blue instance.
Cool.
And once everyone is moved, you can change your green one as well and make it 3.1. So that's again just a concept. You can do that using the cloud services. So of course you also need a router in the front who will change this directions, right? So if a user comes, user is not saying I want to go to blue one or green one. User has no idea. It's the router between which you have to configure to mention, okay, which one is live and which one will be idle. Now it's not actually a good idea to use both of them at the same time. If you think, okay, we have 2 instances, let's use both. Again, there will be a problem when you want to upgrade it. So the users who are using the second instance will be facing issues. So that's it from the blue-green deployment. Let me know your thoughts in the comment section, and let me know if you need such more videos in the
future. क्लाउड नेटिव वर्सेस क्लाउड रेडी, ये एक और थ्योरी है. उसके बाद हम लोग एप्लीकेशन से मूव करेंगे. उसके बाद पूरा प्रैक्टिकल है. नाइस, ठीक है. 17 मिनट एक और थ्योरी लेक्चर. कूल.
Welcome back, aliens. My name is Arvind Reddy, and in this video we'll talk about cloud native and 12-factor app. Now basically whenever we talk about applications, I'm talking about the enterprise level application. Now initially those applications used to stay in on-premise. Basically every company will have their own servers and they will deploy the application on their own servers.
ठीक है,
But
समझ
then we
गए
have
बात।
talked about cloud, right? Now
Nice.
most of the companies are moving from on-premise to cloud. So basically all the services which we are using nowadays is cloud-based. Even the public application like Google Docs, Dropbox, Gmail, everything is cloud. Now the applications which are used internally in the company, they are also being deployed on the cloud. Of course, not every company is moving into it, but majorly, most of the applications are on cloud nowadays. Now, the moment you talk about cloud applications, we have two interesting terms here. The first one is cloud ready, and the second one is cloud native. And then it's important to understand the difference between these two. See, what we expect from a cloud application is the cloud services. The moment you talk about cloud, it provides a lot of different benefits, right? Benefits in terms of cost, benefit in terms of scaling, and benefit in terms of less issues, right? Now, if you want to achieve that, of course, you have to make an application which will use all those services and which will fulfill the promises, right? But what happens is the applications which are deployed on the cloud are of two types. One is cloud ready, second is cloud native. Now, what do you mean by cloud ready? So let's say you already have an application in your premises, okay, so in your own local server. Now you want to move that particular application on the cloud. You have to make some changes. It's not like you picked up the application and throw it on the cloud. No, that's not how it works. Basically, you have to make some changes to your existing application and you have to make it cloud ready. Maybe work with the environment variables, maybe work with the configuration files, and make sure that you are able to push your application on the cloud and it should be able to use the services. So you are basically making your non-cloud ready application cloud ready, as simple as that. But on the other hand, if you really want to use all the cloud services and if you want to make it more effective, you have to build an application as cloud native. Now, normally these type of applications are new application. Let's say you got a new project and then you have to decide now. Do you want to build on-premise or do you want to use it on the cloud? And the moment you say, okay, that's what we are going for, we want to build an application which is for cloud, make sure it is cloud native so that it can use all the features. But how exactly you make a cloud native application? In fact, the name itself says, right, native, so it is meant for cloud, right? Now, if you want to achieve this, we can follow certain standards and rules. Now, of course, in this world, we have a lot of developers, a lot of companies who want to build the application for cloud. So they thought, okay, can we just create some standards? In fact, Heroku created these standards for you and you can follow them to build a better application for cloud, basically a cloud native application. Of course, right? How do you define a cloud native application? So just follow the rules and you're done. The thing is, these rules actually made long back and now we have few changes, but let's talk about those rules which have been developed at that point. And that is called a 12-factor app. So basically, you have to follow this 12 rules or standards, which is 12-factor app, which they called. In fact, there's a website as well, and you can find the link in description, which talks about all 12 rules in detail. But I will try to simplify it so that you will understand in one go. Now, basically, these are the 12 factors you have to follow to build a cloud native application. Starting from the first one, which is called a code base. Now, basically, what happens is we normally store all the coding files in your folder, right? So basically, when you make a project, you store that in your project, maybe in IDE or any editor which you use. Now, what code base says is if you want to build a cloud native application, you have to make sure that your code base is using a version control. So example, it says one code base tracked in a revision control and many deploys. So basically we can use something like a git here.
और कौन से वर्जन कंट्रोल्स होते हैं? गिट और बिट बकेट तो मेरे दिमाग में आ रहा है. System. एग्जाम्पल गिट है, हाँ हम सब यूज करते हैं गिट. तुम लोगों को गिट अच्छे से आता है ना? डू यू गाइस फील कोई नीड गिफ्ट गिट में? एक पोल क्रिएट कर देता हूँ मेरे को जल्दी से. और बकेट जो भी तुम लोग यूज करते हो. वैसे तुम लोगों ने डिस्कॉर्ड में बोल दिया तो ठीक ही है. डिस्कॉर्ड भी अच्छा खासा चीज़ थी यार, टाइम लगा उसको देखने में। ठीक है, आगे बढ़ाते हैं।
Yeah. So inside Git, you have to make sure that you store your project there in a local, or maybe you can use some remote repositories, let's say GitHub, GitLab, and we have multiple options there. So you should have only one code base. I know you want to use on a different environments, maybe development environment, staging environment, or maybe production environment. So even if you have multiple environments there, make sure that you have only one code base, and that too in one repository. And then you can have multiple deployments in staging, in development, in production. That's your choice, or maybe for testing. The thing is, you should have only one code base for one application. Yeah, if you have one code base for multiple application, so that's where you're breaking the rules. So then make sure that you have one code base for one application. So not multiple code base for one application, and not even multiple apps in one code base. So one code base for one application. Second we have is dependencies. Of course, when you build a project, there are multiple dependencies which you work with. Example, in Java, we have to work with, let's say I want to use some database connection. So if you have to use a dependency for database, maybe you want
से बग डिप्लॉय करते थे, हाँ करेक्ट है।
to do it for logging, you need one dependency for logging as well. Now tendencies, when you build a project, in fact we used to do that in the earlier days. When you build a project, there's a folder which says libraries, and this is where you put all your packages and jar files. You say, okay, for this particular project I got all these dependencies, and then now when you want to basically give this project to someone else, maybe you have an ops team who will deploy the application, now you will give all these jar files as well to them. That's not a good idea. There can be also a problem where you say, okay, this project needs these dependencies, and there might be some version issues. Maybe you are using 2.5 for a particular dependency, and the ops team are using 2.6 or 2.4. There might be some issues, right? So make sure that you have a separate file, like a manifest file. Example, in Java, we use Maven. So basically in this Maven, you mention all the dependencies which you need.
हम देख चुके हैं ना, cool है, chill है,
and then keep it separate. Don't link it to your code base.
Nice.
Now, when you share this code base with someone else, you also share this dependencies, the manifest file, not the actual dependencies, and they can download it with the version and the actual name.
Yep.
So that's how you separate it. Next we have is configuration. See, we have to accept it. We always love hard coding, right? Okay, I'm kidding. So basically what you do is in your code, basically,
जब भी ऐसी कॉन्फ़िग की बात आती है तो मुझे वो याद आ जाता है हमारा क्या कॉन्फ़िग किया था हमने, वो ऑथेंटिकेशन, बाप रे बाप।
You use a URL, you use a username and password. If you want to use a particular port number, you mention that in the code itself. So don't mention any of this stuff, any of the configuration inside your code. That's what it says. So store configuration in the environment. So basically what you should do is create a different file, maybe an environment file or env file, and save all the values there. The advantage would be, even if you change your physical servers or anything related to the environment, you don't have to change your source code. Just change the environment variable and you're done. So the idea is, don't touch your code once it is built. Next we have is backing services. So it basically relates to the above parts as well. So what it says is, have a loose coupling between your application and the backing services. Now these backing services can be a database, it can be some other third-party services which you're using. Example, let's say if you're building an application, and in this application you need some data from the third party. So try to create a separate stuff. Treat that service as a resource. Maybe in future it might change. Let's say currently if you are using MySQL, in future you want to use Postgres. That switching should be easy, right? So in your code, don't hard code the configuration. Don't specify which particular resource you want to use. Just say, okay, I want this resource, and then you can just configure it outside. Okay, for this particular request, I have this resource, and you can use them. So treat them as a resource, not a part of your application. Next we have is build, release, and run. One of the tendency we have is write the application, run it. Maybe you can do that on the production as well. So now we are doing it in the development environment. On the production as well, you will say, okay, I have a code here, let me run it. Don't do that. What you will do is you have to follow a 3 different process: build, release, and run.
सच बता, तुमने किया है लाइव कोड, लाइव साइट पे कोड अपडेट या नहीं अभी तक? अगर नहीं किया है तो मस्त हो तुम लोग। लाइव पे नहीं तो कम से कम तुमने डेवलपमेंट या रिलीज पे या स्टेजिंग एनवायरनमेंट में कहीं पे तुमने डायरेक्टली कोड अपडेट किया है क्या? उसके कोड स्ट्रक्चर में जाके डायरेक्टली अपना कोड पेस्ट किया है क्या कभी टेस्ट करने के लिए? क्योंकि तुम्हारे लोकल पे कुछ रेप्लिकेट नहीं हो रहा था, मे बी है इसलिए। तो कई बार करना पड़ जाता है, बट नहीं करना चाहिए। गलत बात है भाई, गलत बात है, नहीं करना चाहिए।
So what you do is, if you have a project ready, create a package, build it. Maybe in Java, you can do it with the Maven. And once you got your package, maybe a jar file, you can give a release to it, maybe a configuration, environment variables and all those stuff. Now this release will go to the running environment, maybe whatever environment you're using there, whatever servers you have, whatever environment JVM you have there. And then the thing is, when you release it, you have a particular version to it, right? And that is working. The advantage would be, even if you want to make a small change, you will not do any changes in the release version. What you're doing is you're changing in the build. Again, you change it, create a new package with a different version.
It's a different
Every
version,
time you release it, you have a different version to it. And if something goes wrong, you can go back to the previous version. Because let's say now you have released 5.5 and then something went wrong with that, you can go back to 5.4. Or let's say in the 5.5, everything is working, you got a new feature, you just use it, build a new one, 5.6 and release it. So versioning is very important there as well. So create a separate thing, build is separate, release is separate, run is separate. Next we have is processes. Now basically, whenever we talk about web applications, in the earlier days we used to go for sessions or stateful services. So what a stateful basically means is, as a client, if you connect to a particular server for the first request and then you share some data, next time when you connect to the server knows you, server knows who you are, they have the information about you. Is a good thing? Of course, right? Next time when you go there, you don't have to tell everything. You can simply say, I was there, I came there yesterday and now I'm here with a new request. The thing is, by doing this, you are limiting your resources. Basically, you're saying, okay, you got this stateful service, and what if something goes wrong with the stateful service? A client will say, okay, I was there yesterday. The data is lost now. So the idea is, instead of going for stateful, go for stateless, where every process is just a process, it's not storing any data in the process. So every time you get a new request, you say, okay, I got your request, let me process it. And if there's any data involved, the data should be coming from the attached resource. It can be a database or some other server. But make sure that you're not storing anything in your particular session. So we call them as sticky sessions. So don't do that. So every process will be stateless, where you don't have any data. The advantage would be, at any given point, you can remove the process and it should not be any matter, because the moment you remove the process, data is not lost because data is stored in a permanent storage, a database. Or maybe if you want to scale up, maybe you want to get multiple processes and the client will not even know which process it is going through. Maybe first time it went for process 1, next time it's going for process 2, which are the same application, but then we have multiple instances of it. Next, we have
एक बार एक रिपोर्ट का कोड पुश किया बट पुल रिक्वेस्ट मर्ज नहीं हुई, तो डायरेक्ट सर्वर पर जाकर कोड अपडेट किया था. ओह माय गॉड, 2 दिन बाद सर्वर रीस्टार्ट हो गया. फिर नेक्स्ट रिलीज में उसका फिक्स बोलकर कोड भेज दिया था. हाँ, ये होता है, देखो. अच्छी कंपनी में होता है.
is port binding. So basically every service will be having
बट करना नहीं चाहिए ऐसा.
a unique port number for different type of service. Let's say if you're using
आइडल एनवायरनमेंट में इसकी जरूरत नहीं पड़नी चाहिए, बट होता है ऐसा, बट बहुत कम होता है ऐसा.
HTTP, we use 80. If you
बट होना नहीं चाहिए. अगेन
we use a different protocol, we use different port number there. In the same way, whatever service you are building, attach a port number to it. Maybe because we are not sure on which physical server they are, but we are sure what type of service they are providing.
Yep.
So every service will have a port number. So that's why it says export services via a port binding. And that's why when you build multiple services, let's say in microservices, every service will have a different port number. Right? That's how you search for it. Next we have is concurrency. The thing is, different programming language have a different way of doing multi-threading and multi-processing. Now basically in Java, that's the advantage, we have a multi-threading concept. But the thing is, even if you're using multi-threading,
आर्किटेक्ट ने ही सपोर्ट किया था. हाँ, ये तो होता है वही, पर
it can
होना नहीं
scale to a
चाहिए.
limit. Because if you're using a particular machine and you're saying, okay, I want to use multiple threads.
ऐसी चीजें बोलने के बाद बोलना चाहिए ऐसा कि ये नहीं होना चाहिए. बट ये होता है ये.
And I want to use the complete power of this machine. But of course, machine has a limit there, right? Of course, you can do a vertical scaling. Now, let's say if you're using i7 machine and with a 64 GB RAM, and now you're thinking, okay, we have to increase the speed of it and the capacity. You can simply go for i9 processor and you can increase the hard drive to 128, or you can increase your RAM to 128 GB. But still, there is a limit how far you can go with it. That is vertical scaling. So what concurrency model says is, instead of going for vertical scaling, you can go for horizontal scaling, which is the scale out. So basically, instead of using
True, brother.
one machine or one instance, you can go for multiple instances. That's how you should build an application. You should be able to create multiple instances of the same service. Next we have is disposability. The thing is, every time, in fact, whenever you learn a programming language, you learn this, right? Every time you open the resource, make sure you close it. Every time you start the service, make sure you're connecting to the different services which is dependent on. Example, let's say your application is dependent on a database. So the moment you start your application, it should be able to connect to the database.
Correct.
But what about if you want to dispose a service? It should be easy. The moment you say, okay, I have multiple instances now for the same service, and now I want to dispose one service here, it should be possible. And also, you should not lose any data. It can be system failure, it can be any problem, but you should not lose data. And that's why if you feel something goes wrong with the system, if you want to shut down properly also, save all the data in the database so that you can close it properly. Basically, you have to close the connection properly. And also, even if there's a crash in your system, if there's some exceptions, close your resources properly. So that's what you say. It just says fast startup and graceful shutdown. Next we have is dev prod parity. Now this is where the new culture came up, which is DevOps, right? Now this article came way back, but the culture came after that, which is keep the development, staging, production as similar as possible.
As similar as
See,
possible.
in the earlier days, what we used to do is we used to build an application on your development machine, and then there are multiple ways of deploying it on a cloud or a server. So you bundle the entire application, you give to the ops team. Now, let's say they are on holiday or they're busy with some other project. They will deploy your project on the server maybe after a week. And then in the development environment, you have made a lot of different changes. So there's a huge gap between what you're building now and what is being deployed on the server. And it can also impact the environment as well. So let's say on your development machine, you're using Windows and with a different IDE, different runtime. Maybe a lightweight process. Example for SQL, I can give you an example. On your local machine, you're using SQLite. On the server, you're using MySQL or Postgres. Because you don't want to install Postgres on your machine. So in that case, if you are building in a different environment and you're giving it to a different environment, there might be some issues. Of course, the ops team will say, okay, we have to make all these changes. They have to communicate, and there will be a delay between the communication. But what if the dev team and ops team come together and they start working together? So as a development team itself, what if you are developing it and you are pushing the code on the server and not weekly or monthly? What if you can do that hourly? So let's say you made some changes, everything is working properly, you push that to a staging environment and you're testing there and everything goes well, you can push it to the production environment. So the gap will be less now. And also with the help of some containers, let's say Docker. So let's say you're using a Windows machine there and you're using a Docker, you're building an image. Now that image will go to the server, even if that server is using Linux, doesn't matter because you got an image which will run on a Docker, irrespective of which underlying OS you're using. So that's what this says. In fact, we also have a concept of CI/CD, continuous integration, continuous deployment or delivery. So even that is emerging from here. Next we have is logs. These are actually very important. For a developer, every time you are building an application, if you want to see what is happening, you use system.out.println or you print something on your console, right? And that's how you know what is happening, right? So in the if condition, you put, hi, I'm here. Have you tried this? Let me know in the comment section, but I tried multiple times. But the better solution would be create a log file, right? Or maybe you can log on the console as well. But then it works on a developer machine, right? You can see a console directly and you can map it. But if you really want it to work on a cloud, you basically need a proper logging service. And also you might be having a multiple process, not just one. So basically every process will generate a log. So what you have to do is, first of all, generate log from each service. That's how you can monitor the application. And what if something goes wrong, you can check there. And then you can aggregate
रात में अरे ये थ्योरी है ना, थ्योरी का काम ही यही है.
and save it in one place so that when you scroll, you can see all the logs, what is happening. And the beauty is logs are infinite. Every time your server is running and you want your server to run, you can see logs continuously piling up. So you have to use a better service to log everything properly so that you can watch it, you can see what is happening. And the last one we have is an admin process. Now basically, you should be able to admin your application from the outside as well. So maybe exposing some port or using some services. So there should be also an admin service there. So yeah, that's how you follow a 12-factor app and you can build a cloud native application.
Okay.
Initially it will be difficult, but then think in a cloud first strategy, right? That's what you say. Don't build an application for a development machine and then you can say, okay, now you have to move to the cloud. If you really want to use all the cloud services, get a cloud first approach and build a cloud native application with the help of 12-factor app. So I hope you enjoyed this video.
कूल यार, कूल डन। तो अभी क्या बात हुई यहाँ पे, एक बार मैं नोट स्क्रीन पे चलता हूँ। आज का थ्योरी खत्म हो गया, देखो यहाँ पे हमारा ये खत्म हुआ है वीडियो। कल से हमको स्टार्ट करना है क्विज मेकिंग एप्लीकेशन, है ना, क्विज ऐप बनाना स्टार्ट कर देंगे और फिर उसको हम लोग एट द एंड माइक्रो सर्विसेज की तरफ लेके जाएंगे। तो कूल है। थ्योरी इसलिए ज़रूरी है क्योंकि कोई भी कॉन्सेप्ट, कोई भी इम्प्लीमेंटेशन, कोई भी, अभी हम लोग माइक्रो सर्विसेज की तरफ बढ़ रहे हैं तो हमें उसके पीछे का कॉन्सेप्ट पता होना चाहिए। हर एक चीज़ जो हम इम्प्लीमेंट कर रहे हैं वो अल्टीमेटली डॉक्यूमेंट हुई थी पहले, या पहले उसका थॉट आया था और सारे उसमें लॉज बने थे। तो ये काइंड ऑफ जानना ज़रूरी है हर चीज़, ताकि हम एक अच्छी एप्लीकेशन बनाए एट द एंड, है ना। तो काफ़ी मस्त है ये, थोड़ा बोरिंग हो सकती है टाइम्स, आई एग्री, बट ज़रूरी है। ठीक है, तो 12 फैक्टर्स ऐप हमारा ख़त्म हो चुका है। नेक्स्ट हम कल स्टार्ट करेंगे फिर अपनी क्विज ऐप बनानी। आज के लिए आई थिंक वी आर डन। तो चलते हैं, बाकी तुम लोगों को मैंने डिस्कॉर्ड के बारे में बता दिया है, तो होप विल सी यू देयर और मिलते हैं फिर कल, आगे बढ़ाएंगे, क्विज ऐप बनाते हैं और चलते हैं फिर अभी के लिए। ठीक है, देन डन। एक ब्लूप्रिंट मिल गया इससे हमें, करेक्ट, एक ब्लूप्रिंट मिल गया। यप, ओके यारो, गुड नाइट।